This is Unit 12, Day 7, trig applications. As far as I can tell, most of the time the Regents exam is going to give you a trig equation and ask you about the different parts of it. Occasionally they had you graph a word problem, but not very common. They'll use the word sinusoidally quite often. If they say a graph or a situation is sinusoidally, that means it's either a sine or a cosine graph. Sines and cosines can be transformed into each other. So just know it's either sine or cosine. As you stop your car at a traffic light, a pebble becomes wedged between the tire treads. When you start off, the distance of the pebble from the pavement varies sinusoidally with the distance you have traveled. The period of this is the circumference of the wheel. Assume the diameter of the wheel is 24 inches. So they wouldn't have had to tell you the period. That would be something you would have to figure out on your own in most cases. But if you have a wheel and the diameter is 24 inches, okay, so basically what we're saying is then the pebble gets stuck in the wheel when it's at the bottom, which we would, of course, being the road, will call, distance or height 0. And then you got to think about the tire moving. All right, so if I sketch a graph of this, here's my 0, and as the tire starts to move forward, my pebble starts to move up and up and up, and eventually it reaches the top of the tire, and then it's coming down on the other side of the tire until once again it is back on the ground. So we end up with a curve that looks like that, which is an upside down V, making it a cosine graph. Okay, now for those of you who are going, but wait a minute, it starts at 0 and sine graphs start at 0. Well, yeah, but it's in the shape of a V, which makes a cosine, and it has been shifted so that the bottom of the V is at the 0. So they're going to want us to write the equation of the function and then make a prediction with it. But for the equation, based on our last lesson, you're going to want the midline, the amplitude, and the period so that you can find the frequency. So the midline is halfway between the lowest and the highest points. So the lowest point is on the ground, which is 0, and the highest point would be up here at 24, which is the diameter of your tire. So halfway between 0 and 24 is 12, so your vertical shift is 12. Now think about it. What does that 12, that midline, actually mean in reference to the tire? Well, if you go up 12 from where that pebble is, you have the exact center of your tire. So the midline, the vertical shift, also represents the center of whatever circular object you are dealing with inside the question. All right, amplitude. Amplitude is how high it goes above the midline. Well, if the midline's at 12 and the highest point's 24, your amplitude then is 12. The period they gave us was the circumference of the wheel, which should make sense because it's how long it takes to complete one cycle, which one cycle would be one trip around the tire. Circumference has the formula of pi times diameter, so the circumference is 24 pi. So the period of this graph is 24 pi. Frequency, we use our formula. Period equals 2 pi divided by frequency. Cross multiply. 24 pi f is equal to 2 pi. Divide by 24 pi. Okay, f equals, the pi's cancel out and you get 1/12. So the frequency is 1/12. So writing the equation, y equals, amplitude is 12. Because the cosine graph is upside down, we're going to make that a negative 12 for our equation. Okay, so negative 12 cosine frequency x plus midline. Predict the distance of the pebble to the pavement when you've traveled 15 inches. So it did say that the x was the horizontal distance. So we're going to fill in a 15. Now make sure, because these are trig equations, that your calculator is in radian mode. For when I plug that in. So let's see, we have negative 12 cosine 1/12 times 15 plus 12. The 1/12 times the 15 should be in its own set of parentheses because you have to multiply those together first before you take the cosine of it. And I am getting 8.2 inches to the nearest tenth. Okay, it didn't say what to round to because I usually forget that part. Alright, so the distance would be 8.2 inches in the air. Alright, so again, for the word problems, it's very much like writing the equations. You're going to need the midline, you're going to need the amplitude, and you're going to need the period. Those will answer most of the questions that you are going to see. So the rest of these give us the word problem and the equation and ask us questions about it. An ice cream truck that plays loud music is circling Boulan's neighborhood. C of T models the volume of music in decibels that Boulan hears T minutes after the truck arrives in her neighborhood. Here T is entered in radians. How long does it take for the truck to circle the neighborhood? So how long does it take to circle is the period. How long does it take to make one cycle? So from the equation, remember this is your amplitude, this is your frequency, and this is your midline. So period is equal to 2 pi divided by the frequency, which is 2 pi 15ths. Keep it, change it, flip it. 2 pi's cancel out. You end up with 15, and T is measured in minutes. Make sure you put the label on there. So it takes 15 minutes for the truck to circle the neighborhood. That's the period. How loud does the volume reach? Well, if we had an upside down cosine curve here, then I'm looking for the y value of the hump. Well, if you remember, you have a midline that goes through the middle of your graph, and the amplitude measures how high above the midline your graph is going to go. So you need both the midline and the amplitude. So from the equation, the midline is 65. The amplitude is 15. Remember, the negative just says that it's upside down. It's not amplitude. Amplitude is 15. It's always positive. So if I take that 65 and go up 15 more, then that tells me that that music is going to get to be 80 decibels. So you take your midline, add your amplitude, and that's your highest point. If you took your midline and subtracted your amplitude, that would be your lowest point. They didn't ask us for that. How loud is the music after 15 minutes? All we're going to do is plug in the 15. Alright, when I do, the 15s cancel, so it's really negative 15 cosine of 2 pi plus 65. Now if I wanted to be wimpy, I could type it into my calculator and just spit it out, but you guys should know this. This is one of the ones that we had you memorize. 2 pi is all the way around the circle, so that's basically saying 360 degrees. So what's the cosine at 360? Well, that should be a 1. So this is negative 15 times 1 plus 65, which is going to give you 50 decibels. And of course, like I said, as long as you're in radian mode, you could just type that right in your calculator and it should also tell you 50. Number 2, a kayaker is drifting in the Atlantic. The ocean is relatively calm. The movements of the waves can be represented by the equation below, where t represents the time in seconds, h of t represents the height in meters. What is the maximum height of the wave? So we have a sine curve here, and sine curves look like that. So your midline goes through here. We are looking for that point. Well, again, your highest point will be whatever your midline is plus your amplitude. So on this one, it does not appear as if there is any vertical shift. There is nothing being added onto the edge of the equation, so your midline is 0. The amplitude is in front of your trig function, which is the 2. So 0 plus 2 means that the highest height is 2 meters. How long does it take the kayaker to travel from the top of one wave to the top of the next wave? Well, here's the top of this one. So that means I'm not starting at the beginning, which is, at the ocean level when it's calm. I'm going to start at the top. So I have to go to the top of the next wave, which still makes one full cycle. See how it kind of almost looks like a cosine curve now? So the top of one wave to the top of the other wave is one full cycle, which is the period. So period is 2 pi divided by the frequency, which is the 2 pi ninths. So keep it, change it, flip it. The 2 pi's cancel out. And how long does it take? It takes 9 seconds to get from the top of one wave to the next. How many waves does the kayaker travel over 1 minute? Well, let's think about this. The period is 9 seconds. So that means every 9 seconds I travel over a wave. So if I take the fact that a minute is 60 seconds and divide it by 9, that should tell me how many waves that I travel over. 60 divided by 9 gives me 6.6 repeating, so that would be 6 whole waves. Nina is playing her accordion by compressing and stretching it. The accordion's length in centimeters, t seconds after it's completely stretched, is modeled by A of t. Here's t entered in radians. What is the length of her accordion when it is completely stretched out? So this is a cosine curve and a positive one. So it's going to kind of look like that. So what is the length of her accordion when it's stretched out? So here is when it's compressed, and here is when it is stretched. Alright, so we have a midline of 65 and an amplitude of 25. So if I take it at 65 and add the 25, that would make 80 centimeters to stretch it out. Likewise, if I had subtracted 25, that says that it would be 40 centimeters not stretched out. Alright, how long does it take her to completely stretch her accordion? I'm going to have a question in parentheses. Is this the whole period? I would argue no. Because down here at the minimum, that's when her accordion is completely compressed. And up here at the maximum is when it's completely stretched. So it actually only takes a whole period. A period is one full cycle, and the cycle is stretch, compress, stretch. So we only want half the period. Well, period is equal to 2 pi divided by the frequency, which is pi. So the period is 2 seconds. Which means, how long does it take her to just completely stretch it? 1 second, because we got to cut it in half. It's only half a period. How long is the accordion stretched out at 30 seconds? Well, all we got to do is fill in the 30 because t is time. Remember to have your cosine in radians, or sorry, your calculator in radians. Just type it in. And I am getting 90 centimeters, which makes sense because I added wrong on the first part. So what is the length of a accordion completely stretched? 25 and 65 make 90 centimeters, not 80. Hopefully you guys caught that error, because there's no way that it could be 90 centimeters if the completely stretched is 80. So that's how I knew I made a mistake. Alright, so 30 seconds, her accordion is completely stretched out. Alright, number 4. Following trig function models the position of a rung on a water wheel, where t is seconds and y is the number of feet above water level. What is the diameter of the wheel? Well, we saw with the tire problem in the beginning that the circumference of the wheel is equal to the period. And circumference is pi times the diameter. So we need to find the circumference or the period of the wheel. Alright, so for part A, the period is equal to 2 pi divided by the frequency. So keep it, change it, flip it, the pi's cross off, and we get a 12. So that means the circumference of that wheel is 12. So 12 is equal to pi times diameter, divide by pi. So the diameter is 12 divided by pi. Now it did not tell me to round it or anything, so we're going to leave it that way. 12 divided by pi is the diameter of that wheel. Part B, at the top of the wheel, how high is the rung above water level? Alright, well, we have a negative sine curve, which tells me that it starts, it goes down, goes down the trough, up the hill, and back. Excuse me, so that's a graph of what our equation is. The midline would be right here, and this says the midline is 16. The amplitude is 20. So that says it goes 20 above 16, which makes 36, or 20 below 16, which is -4. The fact that we're going -4 means it's going below the surface, which, if you look at a water wheel, makes sense. Those rungs have to dip down into the water to scoop it. Alright, so at the top of the wheel, how high is it above water level? It is 36. What are we labeling here? Feet. Okay, 36 feet. How many rotations per minute does the wheel make? Well, we said the period was 12. And it says t is the time in seconds. So it will rotate one whole time around in 12 seconds. So if I take 60 seconds and divide it by 12, that means it makes 5 rotations per minute. What is the height of the rung at 30 seconds? We need to plug it in. Alright, so y equals -20 sine, that's going to be a 5 pi plus 16. Now, if you wanted to think about this in your head, come all the way around, that's 2 pi. Go all the way around, that's 4 pi. Go there's my circle. Go halfway around again, and there's another pi. So we're talking about the sine right here. Well, the sine right here is 0. So the answer should be 16 feet. Which, if you look at our graph, 0 is 16 feet. But you can type it in your calculator and just double check. -20 sine 5 pi plus 16. And sure enough, you get 16 feet. Okay, we have one more. A Ferris wheel is 4 feet off the ground. It has a diameter of 26 feet and rotates twice a minute. How high off the ground is the center of the Ferris wheel? Alright, so let's see what's going on. Here's the ground. Ferris wheel can't hit the ground or it's not going to turn. So the bottom of the Ferris wheel is at 4 feet. Buy yourself a little Ferris wheel. It has a diameter of 26 feet. So 4 plus 26 means the top of the Ferris wheel is 30 feet. So where is the center of the Ferris wheel? Well, the center of the Ferris wheel, we said the center of whatever circle you're talking about is the midline. Midline is the average of the highest and lowest. So 4 plus 30 divided by 2 is going to give you 17 feet in the air. What is the period and what does it mean in the context of the problem? So if this Ferris wheel rotates twice a minute, the period is how long it takes for one full cycle, which means a half a minute. So it would be 30 seconds is the period, and it's how long it takes for the Ferris wheel to make one revolution, or turn all the way around once. Alright, you're going to have similar homework problems. Good luck.